In 52nd question, it is asked to arrange the following orbitals sp, sp2 and sp3 in the order of their decreasing electronegativity. Now what we find is that the s orbital having zero angular momentum can approach closer to the nucleus, and therefore it experiences more attractive force of the nucleus, and hence an orbital containing more s character or more percentage s character is supposed to be more electronegative. Now in sp we have 50% s characteristic. In sp2 we have almost 33% s characteristic. In sp3 we have 25% s characteristic. Now the maximum s characteristic ensures maximum electronegativity. Therefore sp2, sp and sp3 have this following order of their relative electronegativities. 53 is a factual question. It is asking which of the transition elements have maximum abundant in human body. Now calcium, not being a transition element, is the most abundant element of metal in the human body. If you talk about transition elements, then it is necessary, obviously it is iron. Iron is the most abundant transition element in human body. Now in 54th question, it's a very good question. We have to arrange HCl, NaCl, acetic acid and sodium acetate, their limiting molar conductivities in decreasing order. Now what we find is that acids, HCl or acetic acid, they furnish H plus ion. Now H plus and OH minus have very high limiting molar conductivity. They have very high conductivity because their migrations are not similar to the migration of other cations or anions, and therefore HCl, which furnishes H plus ion, and acetic acid, which furnishes H plus ion, they both have very high limiting molar conductivities compared to other salts like NaCl and sodium acetate, and hence the order as per the question is HCl having maximum limiting molar conductivity, followed by acetic acid, both are acids, then salts, sodium chloride and sodium acetate. In 55th question, it is asking if you dissolve alpha D glucose in water, what will we obtain? Now alpha D glucose undergoes mutarotation in water, and gradually comes in equilibrium with its beta form, as well as some traces of straight chain form is also obtained. The major thing which is present in solution of glucose is alpha glucose and beta glucose. Generally beta is more stable, so we get 64% beta glucose at equilibrium and 36% alpha glucose. In beta we have all the OH in equatorial positions and bulkier groups, therefore it is slightly more stable than alpha glucose. So at equilibrium we have 64% beta D glucose and almost 36% alpha D glucose.